right, so we are doing the last set of notes for the year, for 2020. This is it, and they're short, okay? So just a little bitty chunk of notes left. That's all we have. So again, we're finishing notes 28. So note 28 was naming the compounds. So we did the formulas for the compounds. Now writing the names. We've already done regular ionic, so just one metal, one nonmetal. Then we did one metal and polyatomic ions. And now it's molecular compounds. So this is back to the non-metal compounds where they are named differently. Okay, so let's do this. Here we go. All right, so a molecular compound, let's remember, is all non-metals. That's how you know when do I use this set of naming compound rules is if they're all non-metals. If on the periodic table, in our little mock periodic table here, if they're all over here, across the stair step, if they're all over there, they're non-metals, and they are making molecular compounds. So we name them like this. So the non-metal bonds, they share electrons. Remember, so if they share electrons, there are no charges. We do not crisscross anything. So if there's no charges, then how we know how many's in the compound is by their prefix. Those di, tri, deca, hepta, nona, those things have to be used to tell us how many in the compound, because it's not like an ionic where there's a fixed number it has to be because the charge is swapped. They can share in all kinds of ways. So like sometimes they might share with one, sometimes they might share with two, sometimes they might share with three. So the only way to know how many they're sharing with is to have it named correctly with the right prefix. Okay, so let's quickly write down the prefixes here, just so we don't have to go back and look for them up there. So you have mono, di, tri, tetra, like Tetris has 4 sides, so tetra, and then penta. I'm going to go below it. Then we have hexa, hepta, octa, nona, and deca. Okay, so those are all the possible prefixes to use. It's never going to be more than 10. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now, name the first element with the prefix only if there is more than one. So what that means is if there's only one of them, like this one, there's only one C. Normally the prefix is mono, but about 10 years back or so, they stopped putting mono on the first element, just, I don't know, I guess for to make them shorter. They just stopped requiring you to write mono if it's the first element. So I'm just going to write its name. So C on the periodic table is carbon. I'm just going to write it. No changing anything to it. Just writing its name, no prefix needed. Then it says, name the second element with the prefix that it needs. So I look on the periodic table. I look for Br. Br is bromine. Now this rule should kind of be added here. We still change the ending to I. So the name is still changed to I for the second element. So bromine is going to become bromide, like that. But I need the prefix. I'm out of room. It's supposed to be tetrabromide because there's 4 of them. You're right, smaller. Tetrabromide, like that. There you go. So I just tacked on the prefix. So see, as long as you know your prefixes for these and you've recognized they're both non-metals, these are easy. You just write a prefix attached to it. So, okay, next one. I name it normal. So just whatever name it is on the periodic table, you write it, but I put the prefix in front of it if it's above 1. So it's a 2, so it's chlorine 2. So that's di. So di is the prefix for 2, and I look for Cl on the periodic table, and that is chlorine. I don't change it to chloride on the first element. The first element you leave as is. So it's just dichlorine. And then I name the second one. The second one gets the prefix it needs. So 7 is hepta. And the second element gets changed to I. So oxygen becomes oxide, but it's going to be het oxide. Now, you may notice that I didn't put the hepta, I just put heptoxide. Anytime you have oxygen, they don't put the vowels at the end of the prefixes. So like mono, it wouldn't be monooxide, it'd just be monoxide. You leave off the O. If it was tetra, like tetraoxide, they don't say tetraoxide, they just say tetroxide. Like they leave off the vowel at the end. Why? If it was just a naming rule that they decided on, that every time they have oxygen, they leave off the vowel, so it's not two vowels next to each other. Seems a little weird, but I didn't make the rule. So usually it would be a hepta, but with oxygen, they always leave off the vowel. All right, let's try another one. So again, my prefix for 2 is di, so I know that. The first element you always just name as is, no changing. So I look up N on the periodic table, and it's nitrogen. So there we go, dinitrogen. The prefix for 5 is penta, but I notice it's oxygen again, so I'm not going to put the pet instead of pent. There we go. So I'm not going to put the penta like I normally would, because it's oxygen, leave off the A, and oxygen becomes oxide, because we always change the second element to ide. All right, last one. We have an N, there's no prefix. I don't have to put mono on the first one, so I'm just going to name it nitrogen, no changing on the first element. And then again, there's no number, so that means there's only one, but I do put the prefix for 1 on second elements. So the prefix for 1 is mono, so I put mon, and again, I leave off the vowels. I don't know why we chose some of the oxygen examples, but when it's oxygen, you leave off the vowel ends. Instead of putting mono, I'm just going to put mon oxide. If it was anything else, it would be mono. I would leave the O attached to it. Why is it not calibrated at one spot? It's weird. It's like everywhere else it was letting me. Now it's not. Now it's like it just all of a sudden stopped being calibrated. There we go. All right. Okay, let's answer this last question. We're done. Would you name the compound Ca3P2 using the molecular rules, the binary ionic rules? Binary means a metal with a non-metal, just 2 elements. That's the notes they were on. It was just when they had 2 elements only, 1 metal, 1 non-metal. The molecular rules, remember that's what we just did, non-metals only. And then the ternary are the ones that have the polyatomics. That have the polyatomics in them, and again, they are a metal with a polyatomic ion. So that's what the ternary rules. So I'm going to look at Ca3P2 and see which one does it fit. So I look on the periodic table, I see what Ca is. Ca is a metal in group 2, and P is a non-metal. Okay, so it's a metal or non-metal, it's 2 elements only, and that fits this one. Binary means 2, it's a metal or non-metal, so that's ionic. So it's I would name that one using my binary ionic rules. Because you're going to be allowed to use your notes on the test. Because naming is like, you can't really cheat that much unless I give you the exact one that we did as an example in notes, which I try not to do on the test. So really, you're not going to be able to cheat necessarily from these. You can just cheat by using your rules. And if you know how to use the note rules, to me, that's really good enough. So if you can tell that the Ca3P2 needed to be using the binary rules, then you should be able to know how to do it, hopefully. Okay, so that's kind of the process, as you'd be given this on the test, Ca3P2, and you wouldn't use these rules and tell me it's tricalcium diphosphide, because that's not how I name a binary ionic. Binary ionic would be what we did on day 1 of naming compounds. It's this, binary ionic. And remember, you name the metal, calcium, and then you change the non-metal to ide. So it would just be calcium phosphide. Like you wouldn't need the di-tri stuff, because that's not how we name ionic compounds. Okay, finished with notes. Need to pause the video. There we go.